So in this demonstration, we have a pulley attached onto a table, and I'm just going to quickly show you the motion. So here the strings are taut, or the string is taut. Okay, there's a tension acting on particle A, there's a tension acting on particle B, and there is a tension acting on the pulley as well. Okay, so what we have to think about is the question is going to ask us, or is asking us, that's particle A. What's the distance that particle A moves when this system is released from rest? So now the system is at rest, and most students think that it's just going to be the same as this distance. So let's say that distance is, here it's roughly 10 centimeters, probably a little bit more. Most students think that the answer is there. Okay, that's where the answer is. So if I put this little bottle here for you, that's where most students will think this particles would stop. And according to my question, I've been told that this distance is 0.9 meters. So I'd assume that when I release particle A from rest, that it would stop at 0.9 meters from where it started from. But if I release this, let's see what happens. Let's see what happens. Wow. So you can see that the particle did not stop at where I expected it to. It carried on going forward. And this is where it actually ended up stopping, just before it reached the pulley. And we're going to be thinking about the motion. So there's different parts of the motion to really analyze. The first part is when the strings are taut, we're going from this point all the way across. The strings are still taut. So that's S1. That's the first part of my motion, and that's going to be equal to the distance at which particle B was above the ground, which in the question is given to us as 0.9 meters. But at this stage, the string now becomes loose. The string becomes loose, but it still carries on going. It still carries on going. But then it stops itself. So at this stage, you have to think about that. The final velocity of particle B becomes the initial velocity of particle A. That's a very important concept. The final velocity of particle A becomes the initial velocity of particle B. Final of B becomes the initial of A. As that happens, this carries on moving. However, the acceleration is not the same as when the string was taut. Now you're going to have to work out the new acceleration, which is actually going to be negative, because as you can see, the particle slows down and it comes to rest. So it must be negative. And to work that out, we use our force diagram again for particle A, but without the tension, without the T. You use F equals ma without the T and work out what your new A is. So you've got your new A for the second part of the motion. You've got your U for the second part of the motion, which is the V for particle B as it lands on the ground. And also you know what the V of the second part of the motion is, as it's 0 because it comes to rest here. So you've got 3 pieces of information for your SUVAT, and with those 3 pieces of information you can work out what the second part S is. The second part of displacement is S2. Once you work out what S2 is, add S2 to S1 and you've got the total distance that particle A has moved from its initial point, which is there, initial point, to its final point, which is there. And that is the whole concept behind this question. And just to finish off, I've got this system just to remind you that we use the same kind of thinking when we're doing these questions. Because when this is released, that's going to hit the floor. When it hits the floor, the final velocity of this particle becomes the initial velocity of this particle as it's moving up and the string is loose. So it's very important to understand the concept of the final velocity of particle B becoming the initial velocity of particle A when the string is loose. And just to quickly show you, you can see that the string became loose, it went up and it came down. So please make sure that you really think through, and that's why I'm making this video, because these are the 2 pulley systems that you learn in year 12. In year 13, we will get these models to be a bit more complicated with different angles for our strings with this pulley. So in year 13, you're going to have a different setup, but the concepts will be very, very similar. So please make sure you think about them and really apply them to exam questions. Yes?